Hello everyone, welcome to my channel. Today I'm gonna share with you a very special content from real aviation life. My name is Engineer Pilot. I am a real life Boeing 737 pilot and I fly for a commercial airline actively. And in this channel I will try to share some of my real aviation life experiences with the real aviation procedures. And today I will try to share an arrival and approach video to the one of the most challenging airports in today's aviation world. This airport is located at the southwest of Turkey and it's called as Dalaman International Airport. Let me share its location from the map. As you can see, Dalaman is a small village which has a coast to the Aegean Sea at the southwest of Turkey, and it's very popular vacation village, especially during summer times. There are a lot of flights, the charter flights coming to the Dalaman from all parts of Europe, Russia, especially from the Great Britain. So it's a very popular place. As you can see, the airport is located at the seaside. It has only one runway, 01 and 19er. And let me show you some funny and nice views from Dalaman. It's very close to Fethiye, another popular vacation place which British people likes to visit, and there are also a lot of hotels at the seaside. I highly recommend you to visit this such a nice village for a vacation. Anyway, let's continue with our video. As I mentioned, this video content will have full arrival and approach procedure to this challenging airport. Before fully starting to arrival, I will pause the simulator and I will make a briefing about this arrival and approach procedure, and then we will start the simulator again. Alright, as I mentioned in the beginning of the video, this is one of the most challenging airports in today's aviation world. But why it is challenging? Well, there are a couple of reasons why this airport is challenging, especially when we check the arrival and approach charts. As you can see, the north side of the airport is surrounded by high terrain. This is one of the reasons. By the way, as I mentioned, there is one runway and the direction of the runway is 01 and 19er. Approaching to runway 01 is quite usual and no special issue is existing for the runway 01. It has a ILS approach with a 3-degree glide path. We are approaching from the seaside, south of the airport, and nothing special about it. But when we take a look at the runway 19er, as I mentioned, you have to perform your approach from the north side of the airport, and as I mentioned, north side of the airport is surrounded by high terrain. But this is not the only reason for the approach to this runway. For the challenging of the approach of this runway. When we also take a look at the descent angle of this approach, we will see 3.5 degrees descent angle, which is slightly higher than the usual 3 degrees glide path, and especially after initial approach fix Atmon waypoint, you are approaching between the mountains and you are experiencing some mechanic turbulences due to these mountains, and when you approach with a 3.5 degrees descent angle in a turbulent weather condition, it's somehow quite difficult to keep airplane under the desired energy state. I mean, it's quite difficult to keep airspeed under control during this approach, especially if you are also experiencing a tailwind during this approach, which is quite common, by the way. Keeping the aircraft under control becomes quite difficult during this approach. This is another reason. Well, the other reason is that the final approach course is, as you can see, 205 degrees for this approach. However, the runway heading is 190 degrees, which means that you will have 15 degrees offset during the approach, which is also not quite common issue for the straight-in approach. Therefore, this 15 degrees approach, the 15 degrees offset is another reason why this airport is challenging. And also one more thing, as we will descend with the 3.5 degrees descent angle, the chart says that we will see the puppy lights. However, when we check the ground charts, we will see that puppy lights are adjusted according to the descent angle 3 degrees, which means that guidance of puppy lights may be confusing during the final approach. It means that we will probably see 3 white, 1 red during the final approach, and this is also one of the unusual things and one of the things that we should consider during our approach, and this is also another reason why this airport is challenging. I mean, let's say not the airport is challenging, approach to the runway 19er is kind of a challenging approach. And For the runway 19er, I forgot to mention about that. There is no precision approach procedure. There is another approach type, localizer approach, is existing for the runway 19er without a vertical guidance. However, the descent angle for the localizer approach is 4 degrees. Therefore, this RNP approach procedure is usually preferred by the ATC and the airliners. Alright, when you are planning to perform to land on runway 19er, you will generally use RNP approach, and you start this approach with an arrival of Atsal 1 Zulu if you are coming from the north side of the airport. When we check the Jepson arrival chart notes, as you can see, Dalaman International Airport, Jepson chart number 10-2 Juliet, it's effective until 15th of June. Arnav Star airport elevation is 20 feet. The notes are radar required, PR nav approval required, otherwise advise ATC descend as cleared. At Salwan Zulu will be our arrival, and for initial, intermediate and final approach refer to RNP approach runway 19er chart. We will check it later. Caution, only available for traffic able to execute RNP approach. Advise ATC at first contact by the phrase request RNP approach runway 19er, otherwise expect radar vectors for circling runway 19er. Alright, generally airliners prefer to fly RNP approach for runway 19er rather than the circling approach runway 19er. According to this procedure, we are approaching from the north side. We are crossing Atsal at flight level 170 at or above. Let's check it from our CDU on the legs page, as you can see. And then Bravo Sierra 706 and Okmun. We have 240 knot speed restriction at Okmun, and then Bravo Sierra 119 and Bunun, then Atmon. As you can see, we continue according to the chart. Atmon is our initial approach fix according to our chart. After Atmon, we will probably experience some turbulence during the approach. Bravo Sierra 115 Pupel LDAT, which will be our final approach fix in this case. Then Bravo Sierra 116, 117 and missed approach point runway 19er. At this point we will be expecting to see the runway, and we will continue to land. As you can see, we will also experience an offset during the approach. We will talk about it later on during the approach, how we will handle this offset. Okay, RNAV approach, final approach course are 205 degrees are already set on MCP. LDAT mandatory 3400 feet, which we already checked in the CDU. Our minimums will be 1020 feet, which is also set in our PFT. Runway elevation is 20 feet, which means that according to my company procedure, we have to be stable at 1020 feet, otherwise we have to execute go around procedure. Let's check the go around procedure from our legs page. we are coming to missed approach point, then Bravo Sierra 111, Bravo Sierra 112, and continue to Bravo Sierra 113, Asrex and Atmon, and we will continue to climb 9,000 feet. This procedure is also existing in the CDU, therefore we can fly it in LNAV mode. Alright, when we check the approach chart again, we see that minimum sector altitude on the north side is 10,000 and the southwest is 7,000 feet according to Bupel point. Alright, we talked about the puppies, and one of the most critical thing is to align with the runway on the lateral path due to this offset. If we have a if we will have a visual contact with the runway, we can consider to align before missed approach 19er point, because waiting until this point makes the things a little bit more difficult. After landing, just checking the ground chart, we will be planning to vacate via Charlie taxiway. I already checked our performance. Our aircraft is stopping at 2000 meters with the auto brake 2, which is the Charlie taxiway is at around 2000 meters away from the threshold of the runway 19er. Okay, we can just start our arrival procedure. By the way, we also need to discuss or talk about engine failure situation. If we have an engine failure during go around or final approach, we will not execute the go around procedure. We will continue climb on runway heading till the minimum sector altitude. So which means that we will continue to climb directly to the sea, and we can expect some radar vectors in case of engine failure. The risks and threats of this approach is the turbulent weather during the final approach, and keeping the airspeed under control is such a key point for this approach, and also the other reasons that I mentioned at the beginning of the video. We need to consider all of these reasons that make this approach quite unusual and quite challenging. Alright, let's start the simulator and let's talk during the arrival. Our aircraft is descending with the VNAV path mode. General ATC clears us to descend flight level 170 at this point. When we are approaching to Atsal, they will clear us to descend probably to 11,000 feet. Okay, in the original plan, Atmon, there was a 220 knots at Atmon point, but I changed it to 205 below because it is better to cross Atmon with flaps 5 in case of energy management. And Since this is a non-precision approach, according to my company procedure, if you are flying a non-precision approach, you have to be in landing configuration at final approach fixed point, and in this case L dot will be our final approach fixed point. Therefore I put 160 knots below to the L dot point, so I will be aiming to be in landing configuration at L dot point. I am putting a 2 mile circle to L dot as a reminder, and also I prefer to put runway to the fixed page for the situational awareness. I put a circle of 12 miles and 25 miles in order to keep my situational awareness during the approach. Alright, we just crossed Atsal point at 170 below, and we assume that ATC cleared us to descend 11,000 feet. When we check the arrival chart, as you can see, we have a speed restriction of 240 knots at Okmun, so we will execute our arrival according to these published speeds and altitudes. Okay, we forget to make the descent checklist. By the way, I forgot to set the landing altitude to 50 feet. As you remember, the runway threshold elevation was 20 feet, or airport elevation was 20 feet according to the chart. Let's check it. Yes. And descent checklist. Landing altitude 20 feet, set recall, checked auto brake 2 already set, landing data flaps 30, VNAV 141 and minimum 1020 feet. Approach briefing completed, descent checklist completed. By the way, according to latest weather information, we have 2 to 0 degrees 16 knots of wind reported. Therefore, when we think about its headwind component, it's approximately 7 knots. Therefore, I put 7 knots for the wind correction, which we will add our ref speed. So our approach speed will be 147 knots. Let me make you a small reminder. Let me remind you something about the approach speed. Approach speed is set according to the FCTM of 0.737. It says that the FCTM, Flight Crew Training Manual, says that you should add half of the headwind component to your reference speed. For instance, if you have, in this case, we will have 14 knots of headwind during final approach, so we will add half of 14 knots, 7 knots to our reference speed, so our approach speed will be 147 knots. And one other extra information about this: if you have gusty weather, you need to add also gust factor to the reference, to your reference speed. FCTM says that you need to add all gust increment to your reference speed as a correction. For instance, if the weather was something like this, 2 to 0 degrees 20 knots, or 2 to 0 degrees 15 knots, gusting 20 knots, in this case you will have 5 knots of gust increment, so you will add 7 knots because of the headwind and plus 5 knots because of the gust, so you will add 12 knots in total to your reference speed, and your approach speed will be 152 knots in this case. After this extra information, let's continue with the arrivals. As you can see, we are crossing Okmun a little bit fast, then we can consider to use speed brake, because as you know we were supposed to be at 240 knots when we are crossing Okmun, so I considered to use speed brake, and then we continue to arrival. At this point ATC generally clears us to descent 9,000 feet, and I set 9,000 feet at all. Alright, 9,000 feet is set, speed brake we don't need anymore. And also at this point ATC generally says that alright, you are cleared for RNP approach for runway 19er, descent via vertical profile, and we can initially set our final approach fix altitude 3,400 feet. Let's check it from our approach chart. Yes, 3,400 feet, and we will use VNAV in order to comply with the altitude restrictions published in the charts. As you can see, we have slight tailwind during this approach. We always need to consider this. Transition level has passed and we are clear to descend below transition level, and therefore we can set local QNH 1012 in this case, and then approach checklist altimeters 1012, 1012, and 1012 approach checklist completed. We will execute all approach with a LNAV VNAV mode. You can see we are approaching to initial approach fix at Mon. As we mentioned, we were planning to cross Atmon with flaps 5 with a speed of 205 knots or below arm. As you can see, it's quite difficult to keep aircraft in the desired energy state. Okay, speed is decreasing. Flaps 1. FM speed. Since we are crossing 10,000 lights on, arm VNAV speed. Normally it's not like this. It needs to stay at the VNAV pad because we are still in pad. But in B737, when you open speed intervention window, it's again passes to VNAV pad. Okay, flaps 1, then flaps 5. Let's see what will happen when we close the speed intervention window. Alright, it's in the VNAV pad again. Okay, as you can see, at Atmon point. After Atmon, 3.5 degrees descent angle creates some difficulty for us to keep speed under control. Today we are lucky we will have headwind during approach, which is an advantage for us, but if we would have tailwind during this approach, it will be quite difficult to keep airspeed under control, especially passing through these mountains. I keep speed brake in flight detent because otherwise aircraft seems to accelerate. Let's check it. Speed brake I retracted, and as you can see the speed is increasing. In this case we can also consider to use flaps 10. It has a restriction of 206 knots. Let's go for the flaps 10 for more stable approach. Okay, we are approaching to final approach fix the L dot point. As you can see, we are experiencing some light chops when we are crossing through these mountains. Okay, we can also set 1100 feet because we will continue with VNAV, otherwise the aircraft will stop descent. As you can see, the speed is approaching to the limits. Therefore, I will consider to use speed brake again. You see, speed brakes. Runway is around here, but not, we don't have exact visual contact with the runway. Okay, our aircraft is under control. Our aircraft's energy is under control. Our speed is under control. We are descending on the path according to VNAV path. We are approximately 12 miles away from the runway. For the 3.5 degrees flight path, it seems that we are at the correct altitude and we are approaching final approach fix. Approaching flight path here down. As you can remember, we have to be fully configured at L dot point according to our company procedure. And flaps 15, PS arms, the speed brake and engine start switch are continuous. It's done by the pilot monitoring. And flaps 30.
Airspeed low. Airspeed low.
We have some problem. I engaged VNAV again. Descent speed VNAV pad. Okay, you see, oh, we had interesting thing. Retard VNAV speed. Flap load relief occurred. Let's continue. Let's make speed intervention. Defense speed VNAV pad. Let's keep the VNAV pad again. Okay, this was an interesting experience for me, but it's because of some setting in the CDO or some VNAV logic mistake. Okay, just set 147, flaps 30 again. Landing checklist, engine start switch continuous, brake arm landing gear down, flaps 30, 30 and 30 green light. And ATC cleared us to land runway 19er. Okay, now runway inside, we are in the VNAV pad. As you can see, you always need to monitor your aircraft. If something goes wrong, you have to correct it. That's why you are staying in that cockpit. Okay. Now we have two options right now. As we are descending in VNAV pad, first of all, we should not forget to set the missed approach altitude 9,000, otherwise aircraft will stop descent at 1,100 feet. Okay, now we can continue to use automation for the alignment of the runway, and we can also consider to disengage autopilot and autothrottle and continue with manual flight. It depends on you. But since we have a visual contact, it's a good idea to align with the runway a little bit early. Let's use VNAV heading cell mode. Heading cell. Let's align with the runway with the heading cell. I set heading to 0 degrees. Since we are descending in VNAV pad,
Approaching minimums.
okay, we can start to align with runway. Runway inside, continue. Okay. Alright, now we are in the pad. Autopilot to throttle disengage. I will continue to manual flight.
500.
Heading cell, help me. And in this case, flight director switch off. As we expect, puppies, since the puppies are aligned according to 3 degrees.
$200. 100. 50, 40, 30, 20, 10.
Okay, we landed safely. Puppies are not aligned well. That's why we saw 4 whites during the approach, but we were on the pad, and as you can see, we landed to the touchdown zone. So that was a safe landing, and that's it. Thank you for watching my video. I hope you enjoyed it, and see you next time.